recorded. So, again, the final on Monday, December 7th, it's going to be from 8 a.m. as I released all of the midterms and quizzes, right, to the midnight. Okay, sounds good. Let's sing. So let's talk about. So we talked about SHR, SHL, and then ROR, ROL. Those guys from family called logical shifting. Logical shifting normally it targets the unsigned values. So let's target unsigned values. Okay. There is something else. It's called shift arithmetic right. Arithmetic, not logic. Okay. So what is the difference between them? This is more into signed values. For instance, if a certain register like this is 1, 2, 3, 4, 5, 6, 7, 8. So B0, B1, B2, B3, B4, B5, B6, B7. And this is holding signed value. So from chapter 1, the number systems, the most significant bit is representing what the sign. So if it's holding 0, it's regarding to positive value. If it's holding 1, it's regarding the negative value. Do you guys agree? So what the concept of the shifting arithmetic right say? I'm gonna shift not by 0. So here, I shift by 0. Here I shift by 0, and thus I shift by the most significant or the least significant bit, right? For this one, no, we're gonna shift with the most significant bit. Example. So if I would like to shift this at the arithmetic, so shift arithmetic right 1 is equivalent to B7, B7, B6, B5, B4, B3, B2, B1, and the B0 is out. Okay. Now, if I would like to shift arithmetic right 2, so going to be B7, 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 B6, B5, B4, B3, B2, and B1 will be out. Spelled out. I don't care about it anymore. And move forward. What I'm doing here, I'm reserving the sign. Right? Let's have it with numbers. So let's say the number is represented in 4-bit, and the bit number 4 is the most significant bit, is actually the sign, right? Let's make it like the 0, 0, 1, 1, right? So this is the value, and this is the sign. If I shift arithmetic right, or you can write arithmetic, it depends on how you give it luck, right? It's not important, 1. So I'm gonna see this is 1. So this number, this register, it has to have negative all the time. So then in this case, I will just put here 1, 1, and that 1 will be here, and that 0 will be here, and this 0 will be out. So if you look this value, you will find it what? You will find it here 2, and those 2 ones are representing what? Negative. And you move forward. Does make sense? It has a reason why we are learning this, because there is some subject in computers called computer arithmetic. There's even a course here in the university called computer arithmetic. It's not been taken that many years. I don't know why not that many students may be interested. I don't know, or maybe because it's very complicated. It's it's a piece of cake, but
What is
it's
this?
involving math.
I think Jamal had the same question I had. So what is the application of this computer arithmetic?
Division. When you divide, you shift left and shift right for adding and subtract. So you know multiplication, right? Multiplication is what is add and shift. Okay. Division is add and shift and subtract. But then you know subtract also is add. Right? Because you know you have to add to complement, la 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 la, and then you know everything will be add. So the whole entire computer work can do things. Shift, add. This is called logic or logical, and this is called arithmetic. And then you know you play. You make a mix. Then you know, oh, perfect. You would like to make differentiation, or you know, e power x. For instance, you know, how are you gonna make e power x in a computer? I just have add and shift. What should I do? You're gonna use Euler formation, right? Which is basically one. It's almost 1 plus x squared 2x plus x
No series. Yeah, that.
here. Yeah, exactly. Which is look at it. What is this? Add and shift, right? So you know the people who build the computers or computer architect, they build libraries, and those libraries they are add and shift. So you will find a library doing for you e power x. You'll find a library doing for you subtract, multiplication, square, root, whatever. That makes sense?
That's very interesting. I see.
And you can even build a calculator using it. That's really fun to do, you know. If you guys are taking with me statistics also, you know, I can show it to you. But anyway, we learned this, but you know, the question here, every time I keep pushing 0 and 1, so this is actually sequential behavior. Do you guys agree? What does it mean, sequential behavior?
Is it sequential?
Yeah, if it's 4-bit, right? If it's 4-bit, right? I load in the register 0011 like this, right? Then I will start pushing by 0, right? So every cycle I push 0. So that's a sequential. So that's so this is what CISO. It's CISO register, right?
Right, I see.
Or it can be SIBO. It's up to you. You understand what I'm saying? Or you can make it PISO. Like you know, you can bring like this. You push here like this, parallel one shot, and then you know when you get output, you get it like this. So you know, here is the parallel, and here is the serial out. So that's count as a cycle. So imagine the register is n bits. So that means how many bits you will take to shift the whole entire register in cycles. It's pricey in terms of what? Performance. Because you know the cycle, it's a duration of time. Multiply number of cycles in this duration of time, it will give you how many milliseconds? Or nanoseconds, or picoseconds, or femtoseconds, or whatever. Okay, you guys know all of these terms, right? NPS, you know it?
Yes, picoseconds 10 to negative 12.
Yeah. So you know M, micro, nano, pico is femto. Good look. Anyway, so Princeton University, a researcher, they came and say, you know what, this is kind of not acceptable. You know, they didn't use bad words. But anyway, they said, you know, what we can do, we can make it in parallel. So imagine you are shifting in parallel. And they call this what? Barrel shifting. Guess what did you use for this? A network of multiplexers. So the barrel shifter, it's a way using combinational circuit to perform shifting, rotating, whatever. Because what is the difference between shifting and rotating? You push with 0 or you push with this less significant bit. Make sense? So let's see what is this action pair shifting. So those guys came and say, our tool in hand is a multiplexer 2x1. This is the only thing we have in our hand. What is the other tool we have in hand? It's gonna be the knowledge we learn about 2 power 0, 2 power 1, 2 power 2, 2 power 3, which is the distance between the digits. You understand what I'm saying? So that's called distance. And there's something is called in sequencing, it's called edit distance. So it counts the distance between the levels. Our level here are digits. So digits distance is what? This one to here is 1. This one to here is 2. This one to here is 3. Bum, bum, bum.
Oh, I see. So it's going by the power or the weight. I see.
And they came into a nice conclusion. They said, no, the power is not enough. They will break the power into the combination. So 2 power 0 is 1. 2 power 2 is what? 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. Who's messing me? Okay. Anyway, so look. So what does it mean? There is a level distance 1, level distance 2, level distance 4, there's a distance 8, level distance 16. What this guy is talking about, Professor Ali? He's crazy. It seemed that he didn't sleep very well. So let's see what this guy is talking about. So imagine the following. Imagine that I would like to perform parallel shifting for 4-bit register. So I have to define how many multiplexers I need, how many levels of multiplexer I need. Okay? So in theory, if I have 4-bit registers, that means I will have in every level 4 multiplexers. So each level will have 4 2x1 mux. How many level? It's gonna be level log 2 of the 4-bit. Let's see why is log 2. If you have a 4-bit, so that means 0 0 0 1 1 0 1 1. Okay. Now let's see how I'm gonna sort them. Is also by distance. So pretty much let's say that those 4-bit is representing by B0, B1, B2. I don't know what this guy doing. B2, B3. This is the register I would like to do it in a parallel. Okay, let's see how it's gonna work based on whatever I mentioned above here, right? So pretty much I said, I will have 2 what? Levels. Every level will have 4 multiplexers. Let's do it. So gonna have 4 here. This is the 4 in the first level. So that's actually level 1. Let's do the level 2. Level 2. Then when I say level, that means the select of this are the same. So if this is called S0, that's gonna be S1. All of them sharing, the same level, sharing the same what select. Okay. Then everyone it has 0, 1 here, right? So far so good. Okay. Call this V0, V1, V2, V3. Those are the output of the first level. Okay. I have no idea what will be here. I have no idea what will be there. So far so good. So let's see. Let's imagine what we have here and there. So okay, let's look at it really carefully. Okay, so the first one, the first level should be actually facing the IO, the input of this, right? So it has to talk to this. But this one is responsible on the movement of what? 1 of distance. The second will be.
Okay. I found this on the web for responsible on the movement of what one of the distance.
I'm
Your friend. Your friend misses you.
My lord, I didn't get it. Anyway, it's like I even turned it off. Sometime it turned itself on. Anyway, back to this. Anyway, so now I will just say that okay. So this guys will be the B3, and this input will be V's. But let's see how it works, right? So one level is actually the lower, one level is the higher, right? So the distance is 1. We said distance is what? 1. Let's do it. What does it mean? B0, B1. Distance between of them is what?
1.
Let's move. B1, B2. Distance between of them is what? 1. B2, B3. Distance of them is what?
1 again.
1. B3, B0. Did you guys see what I already have done now? Because I do modular. I go in a ring. Because it's infinity for me. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So far so good? Now let's play the game again with the second level. Second level, say distance is what? 2. So in that case, it's gonna be V0, V2. V1, V3. V2 is gonna be what?
V0.
V0. V3 is gonna be what? V1. That makes sense? Let's call the output of this P0, P1, P2, P3. And let's make a table and see whether this guy would perform the rotation or not. They're gonna be making rotation. And then we will make a little bit changes. They're gonna be also, instead of rotation, it will be what? Shifting. And then we'll make another little bit change, then it will shift and rotate at the same time. Sounds good? So let's look at it. So now we need to make our table. We said S0 is the least significant because it's less power. S1 is the most significant, is more power, right? 2 power 0, 2 power 1, right? Then we'll go here and say, okay, 1, 2, 3, 4. Let's actually count. If we have a 4-bit register, how many times we can shift it? 4 times. That's why it's 4. So initially it looks correct. Right? So now we're gonna do like this. It's gonna be here P0, P1, P2, P3, and I have no idea why I made this. Okay. So maybe because I like colors. Okay. Okay, now let's see. If S0 is 0, and S1 is 1, what will happen? Let's see, right? So we're gonna have here some colors because I like colors, you know. So if this 0, so that means that will be 0, like this, right? So that can be like this. So it can be like this. It can be like this. That makes sense? Huh. P0 will be what? It can be like this. Like this. Like this. Like this. Right? So pretty much P0 is B0. P1, B1. So when I have 0, 0, I didn't shift anything. I didn't rotate anything. Right? Let's use different highlighting color for the 0. I don't know why I made this, but it's gonna be like this. Right?
Yeah, I was about to ask about that.
Yeah, it's a side effect of no sleep. Anyway, so now you know for 0, 1, right? So 0, 1, 0, 1. So let's go. S1 is the same. So S1 is gonna be this. Right? Now let's see above what will happen. So above, you know, we need to see the color. So basically, S is S1. No, I made a mistake. I'm sorry. No, I'm right. I don't know why I'm making a mistake.
Yeah, you're right. The only change on S0.
Yeah, you're right. You're right. So the change is gonna be this. Right? So pretty much V0 is what? B1. Right? So let's put it. V0 is B1, but V0 is P0. So P0 is what? B1. Right? Huh. V1 is B2, but P1 is V1. So P1 is what? B2. Huh. V2 is B3, right? And V2 is P2. So P2 is what?
B3.
V3. The moment of truth. Dun, dun, dun. So let's go in this one. So V3 is what?
B0.
V0. V3 is actually P3. P3 is what?
B0.
B0. Can you look at it? What exactly happened?
Well, this is
Is
a
that shift
rotate.
to the left?
I rotate to the right.
Okay, yeah, that always gets me. I know it's rotating. I know rotating.
Wait. I'm gonna surprise you now. You know, I'm gonna build this and then I will show you something more fantastic. You know, wait. So this is basically what to rotate to the right one. Let's apply the second one, right? So what is the second one? Let's have a different color. So the different color said S1 is 1. S1 is what? Is 1. So S1 is 1. Right? So first again, S1 is what? Is 1, right? But you know, S0 is what? We turn it back as before, right? So gonna be like this. Right? Let's now follow this green thing or whatever color it is, right? So P0 is V what? P0 is V2, right?
Just B2.
Is V2, but V2 is what?
B
Is B2.
low. Yeah.
So
B2.
gonna be B2. Okay. P1 is V3. V3 is what? V3 is B3. P2 is what? V0. V0 is what? it's gonna be B0. P3 is what is V1. V1 is what is B1.
B1, yes.
So what is this?
Rotate right 2.
Exactly. Let's do the last one, which is gonna be both of them 1. So let's have it with fantastical color. So everything gonna be what going into this side. Right? Let's see how it's gonna work. We remember some stuff we're gonna talk about now. So let's look at it. P0 is what? Is V2. But V2 is what?
P3.
P3, exactly. Huh? After that, what?
Is it B2?
It's gonna be B2, B1, B0. What do you think? Does it make any sense? Let me check. B1.
I think I messed up.
No, it's B0. I'm sorry. Yeah, now it makes sense, right?
Yeah.
Because in P2, I'm gonna be V0, and V0 is gonna be B1. Yes. Then in P3, I'm gonna be V1, and V1 I'm gonna be B2. Yes. So this is what rotate
Right 3.
right 3. So this table did all the possible thing that we can do. Because rotate 4 is actually what is the original, and I don't care. This is even more efficient. if you want to do it in a left, did you forget the trick I told you about it with in-bit thing? What was the rotation story? Remember, it was rotate left 4 minus 1 is equal rotate right 1.
All right. Yeah, n-1. Yeah.
Right? And you move forward. So gonna be here rotate 2 is gonna be rotate left 2 is equal to rotate right 2, as we learned that rotate right n divided by 2 equal to the rotate left n divided by 2. So what we already have done here is basically rotating operations in nothing, right? Let's look at about the timing, response time. So the response time is analysis not really hard, right? Why? What does a multiplexer look like? Multiplexer generally look like this. This is multiplexer, right? And actually, how it works, multiplexer passing to multiplexer, right? So that means, it's gonna be what? Multiplexer passing to another So if I look to the timing, excuse me, I will find the longest pass is what?
Through the AND gate and then the OR gate.
Let's do it, yeah. This is one of the longest. right? So if you know the gate weights, or you make it NAND equivalency, whatever, you can come and tell me this multiplexer, this barrel shifter will be performing by this response time, and this response time might be actually shorter than one clock cycle in the sequential circuit. Does make sense? Now I'm gonna stop and ask, does it make sense? Do you guys have any questions? Is there anything is not clear? Jeremy, is it clear?
Yeah, it sounds good to me. Just trying to follow.
Luai, how's it going?
I would say like 80%, but I have to still go over it one more time.
Okay, Jamal, how's going on?
That's good. I'm following.
Okay, one.
Pretty good, kind of interesting.
Okay, let me show you the, yes, let me show you the other interesting thing. Now, if I want to be shifting, what should I do? I will build exactly the same circuit. Since I made it with a lot of fancy colors, we can build another one, you know, much cheaper. So gonna be. Huh? Did you see what I did?
Does this say shift arithmetic?
No, it's not. It's not. Yeah, it's not automatic. Just shifting.
Hmm.
I'm shifting right with zero. Okay. So they're gonna be here like this, and then you will just go here like this. I will show you how can you make it automatic. And then you go like this, and they're gonna be here V0, V1, V2, V3, V0, V1, V1, V2. I'm sorry, V1, V3, V2 is what? Should be V0, right? Removes V0, put 0.
Mhm.
Then here V3 is what? V1, right? Put 0. That makes sense? Now we're going to be what? P0, P1, P2, P3. Here is what? S0. Here is S1. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0.
Can you explain why P3 has a 0 on top on the 1? I thought it would be V1.
Everything with rotation, you don't rotate. There is no identical here. When you have to identically push with the same value from the most in the top. So I push here with 0, so that has to be 0s.
Okay, I see what you mean now. Thank you. Thank you.
That makes sense?
Yes, thank you.
Luai, does it make sense?
Yes.
Jeremy, does it make sense?
Yeah, sounds good.
Benjamin, are you okay? Sarah, are you okay? Okay. So what about if I would like to make this circuit perform both of them? It's a piece of cake, honestly. How are we gonna do it? You see that? 0, 1, 0, and B 0. And here I see what row H, like rotate or shift. Okay, and then you will go here V0, V1, V2, V3.
That's actually really cool how you did it so easily.
See, it's a piece of cake, right? That's why series man. So V0, V2, V1, V3, V2. Huh. It's a multiplexer. V3. Not same multiplexer, but almost. So gonna be here 0 and 1, 0 and 1. Here we're gonna be 0. Here we're gonna be what? V2 what? Huh? V0. Here we're gonna be what? We're gonna be V3, it's gonna be 0, and then what? V1. And it's gonna be the same signal, roach. And then gonna be here P0, P1, P2, P3. So if you put ROH equals 0, that thing will be what? Shifting right what? By 0. If you put it 1, that guy will be rotate left and right.
Wow, okay, I see. Wow.
Let's make it more complicated and make it also shift left.
We need more multiplexers.
Exactly. Exactly. That's why it's called network of multiplexing. Let me tell you the rest of the network of multiplexing. So anyway, I would like to stop here a little bit and then ask, everything's clear?
It's clear.
If somebody asks you how to design, you don't need to do this first. You have to go in a scientific steps. Scientific steps, my size of register, this amount. How many levels I'm gonna have? How many multiplexer per level I'm gonna have? The name of the signals of every single level here. And then you will solve the multiplexers. And you will do all of this process. Then followed by what? The timing thing that I made here. Of course, the timing here is different. Why? Because you're gonna take into consideration what? The biggest pass ever you have. That makes sense? So you have to put them together in a big picture like this with all of the gates, and then you will see what is the biggest you can have. That makes sense?
That makes sense. Thank you. All right.
Okay. So in that case, we can yeah, because look, that's here V0, and V0 is coming from a multiplexer. So this multiplexer go into this multiplexer, go to this multiplexer. That means there is 3 stages of multiplexer passing to each other. Then you will take the longest path of it, and then you will write to me here the response time of this circuit, this amount based on the critical path. So if you did follow all of the steps I mentioned, then you prove to me that you fully understand what you know exactly what you're doing. Now, I want you to think with me about how can I shift left and shift right.
So
let's do it shift left first.
mm,
And then, we will combine them together, and then we'll put a rotation with them. Then everything will be in one circuit, Okay. 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1, right? Here V0, V1, V2, P3, P0, P1, P2, P3, let's see what the situation will be, right? So the situation with the left, you are taking 0, pushing toward this way, right? So in that case, 0, 2, right? That makes sense?
I knew it. I was expecting something like this. I was like, oh, don't tell me he's gonna do it.
And then, you'll move forward, it's gonna be B1 to B2, B2 to B3, and then, B3 to what? Uh, wait, B0, 1, 1, 2, 3. There's something is missing, right?
Didn't we forgot P0 technically, or no?
It should be 0. You guys understand what I'm saying? Because think about it, like you already have here like this. B0, B1, B2, B3, right? When you push, right, it's gonna be 0, B0, B1, B2, right? So 0, B0. Oh, 0, B0. 1,
Okay.
1, 0, 1. 1, 2, 2, 3.
Okay, that makes sense. I see.
That makes sense?
Yes.
Then it's gonna be the same. 0, V0. No, 0 is not V0. 0, V2. 0, because 0, V0, V3, V0. Then here, V0, V2, V2, V1, V3. Right? Let's see if it works or not. So we need here S0, we need here S1. I feel it's not correct, but anyway.
I
So
think the V0 per the second multiplexer P1 might be V3. Might. I'm like 50% sure though.
we will adjust it. We'll adjust it.
Okay.
It's 2, 3. I don't use material in front of me. I do it from head. So 1, 2, 3. I don't like use material.
Wow, that's pretty cool.
I invent my material. Same thing. Anyway, so you know what? Because theory will be man. Okay. So anyway, let's go here. So if it's 0, 0, let's see what will happen. 0, 0, that means they're gonna be 0. And they're gonna be 0. So wait. So when you push 0, 0 like this, right? And then here B0, here is B1, right? So pretty much it's gonna be the thing with 0, the thing, right? Let's play. Okay, so if it's 0, 0, so this is 0, 0, 0, so it's gonna be here 0, right? In the B1, this is B1, but it's still here's 9. I think you are right. This is V1, V3, V2. You understand what I'm saying?
Wait, I think the P1 does have a 0 where the V1 is at. Because if it's 0, 0, then it shifts another 0 from the left side, right?
Let me see. Mm,
So like if it's 0, 0 at level 1, it would be B2, B1, B0, and then a 0. And then if you go to level 2,
yeah,
I believe
go ahead, go ahead.
you get B1, B0, and then 0, 0. Right? That's what we're supposed to get.
Yeah, let me see. Left. One second. I'm checking my paper I published before. Yes. I'm sorry. That's 0v0. 0v0, okay? 0v0. 0v1. Okay? 0v1. Then you know what? 0v0, 0v1, v2. Let's see. 0v0, 0v1. Then you know v0, v2. Then v0, v2, v1, v3. Yes. So did you see what happened now? I think that will work. Let's try. So, you know, if it's 0, 0, what will happen? That will be selecting 0, that will be selecting B0, that will be selecting B1, that will be selecting B3, right? Is this correct? Yes.
So the top left one, is that supposed to be a B2 then, or is that also B3?
Let me double check. So 0, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Right. So 0, 0, 0, 0, 1, 1, 2, 2, 3. Should be like that. So in that case, it's gonna be B0, right? Here we're gonna be what? B0. Here we're gonna be what? B1. Here we're gonna be. You know what I'm doing, right? They're gonna be, should be B3, B2, right? Let's see if this happened here. So that 0 will go here, right? That will go here, right? Then you know this 0 will go in V1, right? But then there is 0 here. No, the order will be changed, but still we'll do the same thing. The order will be changed. Let's do it. So let's follow this and see what we'll end up with. Anyway, so if we go in the 0, 0, right? So this will be B0, but still this 0. Then you know, if we go here, B1 is gonna be V2, but this guy is V0. And what is V0 is?
B0.
V0 is 0, right?
Oh wait, B0. Oh yeah.
1 second. Ah. No, it's really, it's flipping. So I just need to fix it now. 1 second. 1 second, 1 second. I don't want it like that. I would like to fix it another way. Any idea? So 0, 0, 0, 0, 1, 1, 2, 2, 3. Because I'm gonna go like this.
Multiplexer.
Huh?
Inputs are switched, maybe. So that when it's 0, it will be B0. And then if it's 1, then it'll be B1 for the top right multiplexer.
You mean here, right? The 0. I can choose 0. If I choose 1, what will happen? If I choose 1, this will be B0, this will be 1, this will be 2, and this will be 3, right?
Yes.
Yes.
Then I think the directivity here need to be changed. The whole trick will be here. You know what I mean? So maybe I can make it V0, 0, right? V1,
That works too.
0. Huh?
I think that works too.
Yeah. Then I make this what? 1, 1. V2.
B0.
0, V3. V0, right? No. It's confusing now.
Last two should be B0, B1 on the left.
Let me see. Let me see. I think the best way to do it is like this. B0, B1, B2, B3, right? If you move like this, right? So it's gonna be here 0, B0, B1, B2, right? And then you're gonna be the second one like this. B0, B1. Then you're gonna be this. All right? They're gonna be like this. I'm right?
Yes.
So in that case, we need to do the same thing as we did before in the top, right? So the first it was what? This one to this one, this one to this one, this one to this one, right? So B0, B1, B2. Let's see if I do this here. B0, B1, B2, B3. Why I have B3? So gonna be here, let's make it like this, 0 to something. 0 to B0, 0, B1 to B2, B2 to B3, B3 to what? To what? Oh my gosh, 1 second. That will be B01, Z1, that will be B01, B1, that will be V1, B2, that will be B2, 3, B3, right? So let's see what I did here. Yes, exactly. That was my mistake. I'm sorry. Okay, so gonna be here B0, B1, B0, 0, B0, B0, B1, B0, B1, B1, B2, B1, B2, then B2, B3, B2, B3. Now you understand what I'm doing, right? Okay, now let's look to this version, right? With this one, right? So this is 0 with B0. 0, 0 with B0. 0 with B0. Who is B0? V0. Right? So it's gonna be V0. Then 0 with B1. 0 with B1. Where is B1? V1. And then B0 with B2. So B0 is what? V0. B2 coming from where? From V2. You know what I mean? Then B0, sorry, B1, B3, right? B1, B3. Who is B1? B1 coming from V1. V3. Yes. Fixed. You guys understand what I have done?
Yeah, that was pretty cool how we use the shift register to see it.
Yes. So Malvin, does it make sense? Hello? Jeremy?
Yep, I'm here.
Does it make sense what we were talking about?
Yeah, so far it sounded good. I mean, I might review it a little bit in the textbook, but otherwise it looks
I'm
good.
just worried about if you will find it in the textbook. So
That's true. I mean, YouTube is always a very good source of, going over things too. So
yeah, maybe, but we can go through it again if you want.
no, I mean, I understand it for the most part. I mean,
But
when I'm going over it again later, I might
one of the shots, we already have here B0, B1, B2, B3, right? We are what building everything toward the shift left. So basically, if you shift this one time, what will happen? You push with 0 and B0 will be here. B1 will be there, B2 will be here, B3 will be out, right? So
Yeah.
that's actually first time. Then this one will be shifted one more time with 0. So that 0 will come, right? Then this 0 will be here. B0 will be there. B1 will be here. B2 is out.
Oh, okay. So it's like as you shift it over, they all become 0.
Exactly. Then I'm gonna shift this one more time, right? So I'm gonna push it with 0. So that's 0 coming here. And this 0 will go here. This 0 will go here. B0 will be here, and B1 is out. Then the last time, I'm pushing with 0. So that 0 is pushing in, and then the 0 will be here. This 0 will be here. This B will be here. The B0 will be out. Okay.
Makes sense.
Now, we are trying to put it into this multiplexing thing. So how are we going to do it? Look, now, this is the original, right? And this is the first shift, right? So the original to the first shift, we need to select the distance, right? So the distance, the new is 0, the previous was B0, right? So that's why the
Yes.
new is 0, the previous is B0, right? Now, the new is B0, the previous B1. The new is B0, the previous is B1.
That makes sense.
The new is B1, the previous is B2. The new is B1, the previous is B2. The last bit, it will be what? The new is B2, the previous is B3. So gonna be what? B2, B3. So we finished the first what? Level of shifting. Now we need the second level of shifting. We need those inputs here, right? How are we gonna do it? Look. So now we are comparing what? The second with the original. Okay? So what is the second and the original? The second is 0, and the original is what? B0. Do you agree? So here is 0. But I have output is called V0. But I need B0. Who is actually the source of the B0? Is actually the only one is what? V0. So I will put the V0. Then here, this is 0 and B1, right? So I'm gonna put here 0, but I need something in V1, but still I need also B1. So I found actually what V1 is a function of B1 here. So I put here V1. Then I move after that. I need B0 with B2, right? I don't have direct contact with B0, but I know B0 is a function of V0, so I put V0. I need B2. Who is actually generating B2 is V2, so I put here V2. Then, I move to the last one, which is basically B1 with B3, right? B1 and B3. Let's go on into it. B1 is coming from the multiplexer, is responsible in V1 because he is B1, so he's B1. Then, I want what I need the B3. B3 is coming from what the source is basically here, the last multiplexer V3. So I put here the V3. We are done. So now if you play with this S0, S1, it will start giving you all of the different combination. So it does make any sense?
Yeah, it actually surprisingly does make sense. Well,
Imagine we are doing this for 8 bits. What you gonna do?
oh,
Come on, embed is easy. Come on.
I need to draw 8 squares.
No, let's do it 8-bit. Let's do it 8-bit. Jeremy, can you do it with me? We'll do it together. Okay.
Sure.
So let's go into the 8-bit, and this 8-bit is gonna be left. Let's make left. Left is easy. To the right. So 8. That means I have 8. 1, 2, 3, 4, 5, 6, 7, and 8. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Right? We know that it's 8-bit, so log 2 of 8 is how many? 3. So that means I have 3 levels, right? So the second level will be here like this. Zero one D 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 one. Right? Then the third level.
And the levels are just decided by like what, like the bit to the power of 2 is, right?
Yeah, that's basically what we're gonna talk about. So the control coming from the top to the bottom. So what is the least significant is basically S0 here. Here is S1, here is S2. Okay? And S0 is basically controlling all of this level, right? That
Yeah.
means when S0 is equal 0, all of these multiplexers will be selecting 0. When it's 0, 1, all of this multiplexer in this level will select the output 1. Make sense? Same thing here, for S1.
Is it shift left or shift right, by the way?
That's gonna be right.
Okay, got it.
Right is pretty much, it's a piece of cake, Anyway, so let's look at it, right? Now we know we build it, right? So here we're gonna call V0, V1, V2, V3, V4, V5, V6, V7. This F0, F1, F2, F3, F4, F5, F6, F7. Then this P0, P1, P2, P3, P4, P5, P6, P7. Okay, now we're gonna start filling based on the information, right? S0 is the least significant. So that means it's gonna be 2 power 0. If you would like to do it like this, S0, S1, S2, right? 2 power 0, 2 power 1, 2 power 2, right? 2 power 0, that means, neighbors will be 1 distance, right? So that means, if my input is basically B0 to B7, so they're going to be what? B0 to B1. Distance here is what? 1. Then, I take this B1, it's going to be what? B2. It's going to be B2, they're going to be B3. They're going to be B3, they're going to be B4. They're going to be B4, this is going to be B5. They're going to be B5, they're going to be B6. This is going to be B6, they're going to be B7. It's a ring, right? So after 7, what will happen? You return it back to 0. So they're going to be B7, they're going to be what? B0. So what I did actually, I rotate now. Right? I rotate. Because, I keep pushing like this. So I'm pushing like that. Make sense?
Yeah, so this is rotate.
The B0 will go like this, backward, to be the most significant. Or you can remove this B0 and make 0. It will be what? Shift toward the right. Okay? Now, the second S1 is actually 2 power 1. That means 2 neighbors. So, those are V's. I'm not anymore into B, right? So going to be what? It's going to be V0, V2, V1, V3. Distance between of them is 2. Have you noticed? V2, V4, V4, V6, V5, V7, V6, huh? It's gonna be V8. There is no V8. It's gonna be what? V0. Then you know V7, it's gonna be V what? 9. 9 is what? Modulo of the thing, it's gonna be 1. Right?
Oh, I see now. I see. I see.
Yes, yes.
Modulo. Okay.
V1, then you know, huh? You will move forward and you'll be done. Okay? So here's 0, 2, 1, 3, 2, 4, 3, 5, 4, 6, 5, 7, 6, 8, which is 0, 7 is gonna be 1. Okay, then you know we'll go to F. This is 2 power what? 3. So now the distance will be what? 2 power 2, I'm sorry. 2 power 2, that means 4. So gonna be here what? F0, F 4, F1, F5, F2, F6, F3. It's gonna be actually 4, F7, F4. It's gonna be F8. There is no 8, so gonna be 0. So gonna be F0, F5. It's gonna be F1, F6. It's gonna be F2, F7. It's gonna be F3. Then you will get this. So if you play with all of this combination, you will find it actually is rotating for you. But you know, if you don't want to rotate and just shift, you will remove this B, and then you will remove this V0 and V1, and then you will remove on F0, F1, F2, and F3, and you replace them with zeros. Then the whole entire thing will be what? Shifting by 0 towards the right. Does it make sense now, Jeremy?
Yeah.
For the rest of you, does it make sense?
Yep.
Any questions so far?
This is a rotate right, right? Get it? Rotate right, right.
Which you can make left also, right? With this trick we mentioned about the ROL 4 minus 1, you know, this n minus 1 thing. So do you again? I think we passed the time, but I will tell you this: if you have rotate, if you have n bit register, so rotate right n equal to rotate left n is equal to the original. Rotate right n minus 1 is equal to rotate left 1. Right? Rotate right n divided by 2 is equivalent to the rotate left n divided by 2. That means, you know, if I have 4 bits, so rotate 2 is equal to left, gonna be rotate right 2 is the same thing. If you use this, you don't need to waste your time and make left and right, and you know, just do this, and you know, you will just get one from the others. Anyway, it's past the time, so I'm sorry about that. But you know, if you have any question, let me know. Still, we have Wednesday. I will just go into the rebel carry and just like, you know, warm up you a little bit for the finals, and you will be ready to go. Do you have any questions?
Thank you. Appreciate that. Thank you.
So thank you, guys. It was my pleasure to talk to you. God bless you. Stay safe.
Thank you, Professor. God bless. Thank you.
Thank you.
Thank you.
Thank you, Professor.
Bye-bye.
Professor.
Thank you. Bye.
Also, Professor, I forgot to tell you, I got to covering the SHA-1, and I was actually trying to code the SHA-1 algorithm on my own.
Good. Show me. You know, after we finish this final week, can you show it to me?
Yeah, sure. I'll try to go ahead and build one. But yeah, it's pretty fun actually. So I was just coding it on my own, trying to do it. So I'm thinking of doing it in C++. So I was gonna do it in C#, but it has a
Do it in C++ is better.
Yeah.
Or,
All right, got
or
it.
normal C. Okay.
You got it. C++. Thank you.
Thank you.
All
Bye-bye.
right, Professor. Thank you. Bye-bye. Thank you.